Hello everybody, and welcome again to this course. This is Module 3, and in this first lesson, we'll learn what's an Arduino pinout diagram and how to read it.
I will start with a recap of the most important Arduino models available nowadays. After that, I will introduce a general description of a pinout diagram, and then I will explain what are and how work the most used pins of the Arduino boards. In particular, power, GND, analog, digital, PWM, and additional pins. Let's get started. There are many different Arduino boards available. Each one is different and they are designed to fit most common application. Each Arduino board has a different number of pins, used to communicate with external devices or with external sensors. When choosing a specific board to work with, it is important to decide the minimum specification we need in our application. As we can see, models vary in number of digital pins available to different functions, or in total. As more complex, Arduinos will be bigger and number of connections will increase. This is why it is necessary an easy way of visualize the physical connection in an electronic system as the Arduino. The commonly called pinout diagram is a way of visualize this connection in a quick and a compact diagram. It is a cross-reference between the pins of an electrical connector and their functions. There are two different diagrams that we can find for the Arduino models. It can represent only the central chip or the whole board of a concrete model of Arduino. As each board has different layouts, each board will have a different pinout. Looking for the model of the interested Arduino on the web, you will find the pinout diagram. These are some examples of the Arduino Uno and the Nano. The diagram often includes more practical information about the use of the selected pins. Pins can be divided based on its functions. Now I will review the most important pins that we can find in every board. First of all, the power pins will power the board, so they are the most important pins and they should be handled with care. Powering the board can be done through several ways. The most used are USB connector, plug-in socket using transformers, voltage-in pins, and 5V pins. Always remember to use voltage under the recommended and maximum ratings specified for the Arduino boards. These can be found on the pinout diagrams or the datasheet. There is also a reset button or pin used to reset the board. GND pins are often placed in different pins. They are all interconnected and can be used to obtain a ground signal in our connections. Analog pins and reference voltage pins are used when an analog signal is used or required. Analog input and output pins are available to perform reads of analog signals. To generate analog signals in every board but the Arduino do, it's necessary to use pulse width modulations. On the other hand, digital signals are much simpler to work with. Digital input and output can be performed with specific methods, not without first establishing the function mode of each used pin. As stated before, some digital pins can also work in PWM mode, allowing generating a square wave signal by switching between high and low. The frequency of this signal is constant and the data cycle can be verified to satisfy the user needs. Keep in mind that although it is possible to change the PWM frequency, it affects the internal timers and disrupts the normal operation of many time functions. In addition to these pins, there are some special pins that allow operation that are more specific. They include interrupt pins, serial ports, I2C and SPI pins to provide interconnection with external devices. The most important of these communication connections will be explained in the following lessons. Thank you and see you in the next video.